I'm Gianluca. I come from Italy. I worked for a couple of times in Dublin. Now I'm back to Italy, and I'm working as a site reliability engineer in InfluxData. InfluxData is the company behind InfluxDB and all that kind of product, open source projects that are helping you to put together a monitoring stack or to work in IoT and support all the sensor and all that kind of time series data that we are speaking about today. But I'm not here to speak about time series on monitoring. Today I'm here to speak about Jenkins and continuous delivery. I put together this talk during my last years of experience as build engineer. Before I was working in a company and we had kind of interesting migration path from Jenkins one kind of setup that was not really well used and was not following good kind of methodology. We tried to move over to Jenkins 2 with pipeline and with all what the modern kind of agile and continuous delivery and high flexible environment required. We took this decision to move what we had to something new because we reached the limit where what we have what was more like a problem than a benefit. If you have a Jenkins that is working just sometime, and one time your tests are good, the other time the same test is failing, it's not really something that you like, that your team is well using, and can become a really bottleneck for your team. It can take to you the opposite kind of benefit that you're looking for, and it can become really, really something worse to use. And we decided to move everything that we was doing before to a new kind of pattern. And during this migration, we learned a lot of stuff about how development team lives Jenkins, how they use continuous delivery, and how a build engineering team can do to make this migration easier or worse, depending on how you are doing things. And I try to take all this kind of experience that we made during that time, and I try to make a presentation around it. For this reason, we are not going to learn about how install a Jenkins server, because I think that there are a lot of good blog posts and a good tutorial around that you can just Google. You can use Google how install Jenkins, and it's going to be super easy to do. And we are not going to understand how to work a specific plugin. In first, because I don't like plugins, and in second, because we are here to understand from another point of view how your work as build engineer, or how your work as people that look at the Jenkins server behaves. And in first, we need to understand the role, because for example, in my experience, I went not hired to become a build engineer. I was hired as a software engineer. I understood that we had a problem around how we are using continuous delivery, continuous integration, and I tried to fix it. And after some times, I just realized that a good team and a company that have maybe more than one team and more than a certain amount of person needs somebody that takes care about this kind of stuff, because they are the entry point of your code in production. If your continuous delivery server is down, you cannot go in production. That can become a single point of failure for your company if you can see that in this way. If your Jenkins server, or if your delivery pipeline is not working as expected, you are not able to go in production. If you need to go in production because you have some problem in production, you cannot go because your problem is escalating just to your delivery system. And that's why what we learn is that we need to love our continuous delivery system, because it's going to help us to bring our code in production. In first, I'm happy to make some glossary together and cinch how we speak. And there is a difference between continuous delivery and continuous deployment. Continuous delivery is everything that you do all the checks that you persist and all the artifacts that you create, the Docker image that you push before release something to production. You can make this continuously. You can, every time that you merge your code in the master branch, you can persist unit test, acceptance test, build your package, your artifact, or your tarball, depending on what you are working. But you cannot go in production. You can have your artifact ready to go, and when you are ready, you can deploy it. If you are looking to go in production continuously, you are making continuous deployment, because at that point you have your artifact and you can ship it. Like there are no bad or good solutions. There are great companies that are using continuous delivery and great companies that are using continuous deployment. There are worse companies that are using both. Like depend of you, depend of your team, of your application. There are a lot of use cases. It's just to keep in mind that there are different kind of terminologies. 2 years ago, I was really not in love with Jenkins. I was trying to, when we was thinking about what to do, move out, stay on Jenkins, I was really pushing to move out of Jenkins. But at some point, Jenkins released Jenkins 2 with pipeline and all that kind of things, and I just realized, okay, let's stay here and see what's happened. During that work, I tried to, put together everything that I was looking for from a continuous integration service from my Jenkins. I tried to make it abstract and understand all the pieces that together are creating a delivery system. And this is the really simpler graph that I summarize. You need to have a handler that is waiting for something to happen. It can be a merge in GitHub or in Bitbucket, or it can be a message on Slack. It can be whenever you want, but you need to have an entry point where everything that, the action happen and say, okay, it's time to do something. It's time to run our job. It's time to deploy my code. After that, you need a procedure. You need something that is able to run your check in your code. You need maybe a container or a new service, something that is clean and ready to run your code in an isolated environment. It can be a VM or a container. The important part is that he needs to be clean. He needs to be similar to your production environment, and probably you cannot do continuous delivery without a sort of automation around your infrastructure. But yeah, the idea is that you need to have a place to run your test. When your test is, all your tests are done, you have this kind of sentence: is a success or is a failure. And in both cases, you need to do something after this. When you know that your test failed, you need to notify somebody else, or you need to open an issue. I don't know what you need to do, but you need to persist some action. The same for the success. Probably they are two different actions, because if it's a success, you are happy to go to production. If you have a failure, no. That's the main example. All these pieces come together, but you know this slide better than me, because we are trying to increase the most common metrics that we are trying to speed up when we decide to go for continuous delivery is the number of release that we make in production. Maybe we are not happy about the number of release because we have a release every year or a release every month, and we are trying to improve that number. Continuous delivery is obviously helping you to achieve this goal if you are making it good, properly. And yeah, the idea is that you build something, you deploy your code in a safe environment, you run your tests, and if the tests are good, you release. You can do that in continuous delivery without the last piece in one pipeline, or you can do all together in a continuous deployment environment. There is another term that is called continuous integration, and continuous integration contains all the steps that you are running on your code to understand if it's compliant with all the code that you already have. That's why it's integration, because you are integrating new code in the old code, and you are trying to understand if all the checks are, if the code is compliant. Like this is an example with PHP. You do a pull request on GitHub, and every time that you create a new pull request, you run Composer, that is the dependency manager. In Java, you're using Maven. In Ruby, you're using Gem. Like that's the idea. You need to solve your dependency and have your application ready to go. When you have that, you can run static analyzation or unit test or acceptance test. That's on top of you, depend of how much complexity you have. I follow a talk before in the other room about security, and in that talk, the guy shows a lot of kind of tool that you can use to analyze your code from a security point of view, if there are vulnerability or if there are patterns that are not safe. You can run all this kind of check in your integration test. In this way, before merge a pull request in the master branch, you already know if it's compliant or not. We also have kind of manual step. It usually exists, that is the human review. You still need to have your colleagues that have a look on your pull request, and if it's good or not, you can continue. But for example, in GitHub, there is a feature that is called status. I think that there is also in Bitbucket, but you can you can integrate Jenkins to check your code and say to GitHub, okay, this pull request is compliant. If it's compliant, it's green, it's okay, it can be merged. If it's not compliant, GitHub doesn't show the merge button. It means that nobody can merge that pull request. Obviously, there are permissions that allow some people to merge it anyway, but it's another layer of security that you can use. Zach Holman is one of the first engineers in GitHub, and he wrote this in a blog post. And I really like the idea because it needs to be simple. I'm not saying it needs to be simple in terms of what it does, your pipeline does. It needs to be simple for users. And from a build engineer point of view, the user are your colleagues that are making code and are trying to use your delivery system and your pipeline. They don't need to be crazy. It needs to be simple as start a flame about space versus stub in Hacker News. And I can say that it's really simple to do. Why you need a continuous delivery? I told you that the main kind of metrics can be, okay, I need to do more deploy because my team is growing, my business is asking me for more delivery, and I'm not able to do that with my current flow. Another way to see this is to stay focused on business. For what I learned in my experience, delivery copy-paste code between environment is not your business. Your business is running a write code that build e-commerce or build something that help people to transfer money. In my case, it's build time series database and monitoring tools. But it's not deploy code between environment. My business is completely different, and I'm happy to stay focused on them. Reduce human error is another goal. We saw before that is the word continuous delivery it means that it's continuous happening. It's like a circle that repeats over the time, and we are not really good to make this in a good way, because at some point we maybe become bored to do every time the same task. Maybe it's the end of the day and I'm just happy to leave the office, but I still need to put this code in production, and maybe I will not persist that important check that will break the production environment. For human like me at least, make the same stuff over the time is not really a good challenge. And if I can configure a server to do that for me, that's double win. That's win for both. Another good point that I learned is the communication channel. We have a lot of communication. We use Slack in our company. Maybe you are using Slack too, or HipChat, or every time I open in Twitter because I need to quote these guys sometimes in the slides. And you open email because everybody's using email. And you use your phone to communicate with your mom. we have a lot of channels, and we don't need to add them, another one of them in our stack. My stack is full of communication channels. And what you can do is like configure Jenkins and configure your pipeline to use what you are already using. If your company is using email every time, you can use email. If your company is using some chats like Slack, you can send notification on Slack. It's pretty easy to do in Jenkins or with a plugin, or you can write something that uses the Slack API. Everything has an API, and there is a reason for that. Yeah, another stuff is keep developer focused. As I said, my business is not copy code between environment, and I'm happy to share this stuff with my colleagues in order to leave them focused on what they are doing. And like to be focused on something, your pipeline doesn't need to be too slow, because if your pipeline takes you 15 minutes to achieve all the tests and persist all the check, like I can take a coffee or maybe play ping pong if we have a ping pong table in office and we can play something. But I lost the scope of my work, and I need to come back, and come back on my all the task requires some effort. Another kind of work that we did in our company is try to put together all the terminology and have a common one. We have the concept of release, that it's like every new version that is going to production. We have the artifact that is really important. We didn't have something like this before. Every time that you have a code compliant and ready to go to production, you can put it together in a zip file or in a Docker container if you're using, you can build your Docker image if you're using Docker. And that code is going to be shipped between environments. We was deploying the same artifact between all the environment. I'm going to show you later the hand-to-hand graph of our pipeline. And in the first step, we are creating the artifact, and it's shipped to all the environment as it is the first time. Pipeline is like the tunnel that we follow, that our code follow from the beginning, from the version control to the hand, to the production environment. And we have different way to describe it. I'm going to show you my favorite one, that is not anymore through the Jenkins UI, but it's through, but it's via file. You can use a Jenkins file to specify how your build works, and you don't need to open Jenkins anymore to configure how a job works. Continuous delivery, integration, and deployment, we already spoke about this. And rollback is another concept. It doesn't need to be too complicated, but you need to be aware that your deploy can fail, that your code in production can break all the system, and you need to come back to a safe snapshot as soon as you can. And this is the goal of the rollback strategy. It's probably a very hard kind of topic, and probably you can just start with the idea that when something breaks, the rollback policy is a new build. Like I am working in this way, and I'm not feel too bad to say that. Like you are making a release, you hand your pipeline, and if something is wrong, you just start from the beginning, from an old version in your Git. You can revert and restart. That's the idea. If you are good enough, or you have a policy and your rollback needs to stay in some amount of time, maybe you need to have a complex kind of system. Maybe you need to take snapshot and restore snapshot. If you are on AWS on a proper cloud provider, you can leave the whole virtual machine there and just switch Symlink or the DNS. There are ways to solve this problem. Probably the easier one is just restart from an old version of the code. CI server is our Jenkins, and job is a single pipeline that starts when your code is merged. I put together some other suggestions and goals that we had during our migration, and one is that the pipeline need to be unique. It needs to be unique from a project point of view and for team's point of view. Every team is different, every team is working in a different way, and every project requires different attention. I'm not saying about difference between languages. The language can be the same, but the project can be different, and you need like different steps or solutions. I spoke about rollback before, and that's a point that we need to we need a rollback because yes, our pipeline is our continuous delivery is helping us to move to the future quickly, but we always need to support the past and learn something from the past and maybe restore something from the past if we did some mistake. It's not just something that helps you to move to the future, but it's also something that needs to support you when something is need to come back in a safe version. Another point is speed, velocity. We spoke before that we can stay focused on something for 4 or 5 minutes, but we cannot stay focused on a task that is running forever because we are getting bored. We are not paid to look at the Jenkins build, and we need to in some way make our pipeline faster. There are different kind of way to do that. You can split your pipeline and maybe run some check during the pull request lifetime and run other of them when you merge your code. Depend of you. You can parallelize your pipeline. You can build some commands in parallel. It's on top of you about how to speed up your pipeline. We made both. We have some checks like acceptance tests or smoke tests that are running when we merge code to develop or to master. And we run all the check analyze, static analyzation or unit tests in parallel because they can work in the same time. Make your pipeline reproducible is important for 2 reasons. One, because it allows you to test faster your pipeline. If you are not able to run your task in your local environment or in something like that, you need every time to go to Jenkins and try to run the job and see what's happened. If you can run it in the simple way in your local environment, you are moving faster. And the second reason is if you can run your pipeline in your local environment without all the setup that usually you have in a server with all the services that you have, all the databases, if you can do that, probably your pipeline stays really simple. And a simple pipeline is something that we are all looking for because we don't need complexity, unused complexity. I usually use make because it's easy to have in the servers and local environment, but there are task manager for any kind of languages. Grunt is in JS and Ant in Java. Well, you can use whenever you want. Versionable is another point. Is the first point that was bringing me out of Jenkins 1. Because if you have familiar with Jenkins, you need to open the UI and you need to create a new job. The new job has a box when you can put all the command that you need to run and you save the job. There are problems with this kind of approach because you need to give to all the developers or all the people that need to change that script permission to Jenkins, and you lost the change that people are doing. Let's say that you are adding new tools or you are changing options in some command. How are you going to know why you did that between 2 months? Nobody knows. It's like a black box that nobody was like our memory is going out more than our RAM in the server. And Jenkins 2 has this new concept of Jenkins Pipeline. It's a plugin that you can install. Now with Jenkins 2, it comes really close. When you install Jenkins 2, it asks you if you need to install pipeline. You install pipeline and you have a set of features that one of them is pipeline has code, and you can create a Jenkins file in your repository and put that file in your version control. It means that you are allowing your developer to update your pipeline with one pull request. And that's really good because they don't need to ping you on via email, or you don't need to move your focus to update one command. They can create a pull request, and you can review it and merge as it normal behaves as code, normal code. And another good part is when you have your Jenkins file in your repository, it's growing with your application. It means that probably from a commit, you can understand why you are changing your pipeline. And it's comfortable to roll back if you need. Keep tracking of what you are doing. It's not something that I can see in small company or medium company, but it's really simple to have in place. You need to notify every time that you start a job, you end the job, how it ends, if it's a success or not. Also, the delta between the start and stop is really important because you can see that if there is a spike, if it increases and you don't know why, there is something wrong that you can look into it, and it's another way to optimize your pipeline. There are other reasons to do that. One of the most important one is that when you're running code in production, you are in a kind of stable state. All the code that is in production environment is working in some way. Your code, your application can usually breaks when there is new code that is in production. If you mark every release, I don't know if you can see the red line, but there are red vertical line in the graph itself, and that line is a new deploy. We are making this graph with Grafana and InfluxDB. If you mark that part, you can understand how the new code and how the new version behaves. And if you put in a graph more than one, you can put in a graph RAM, CPU, and network bounded I/O, all in the same graph, and you can compare how the new code behaves in a really easy way. The second reason to track is to make a party. We always need to have a good reason to drink a beer, and when you reach some limits, like 1,000 of release, maybe it's a good way to have another party. Communication layer is really important. We spoke about it already. The goal that we had was to keep people out of Jenkins UI the best that we can. If my colleagues can see everything they need without a login Jenkins, it's great. And not just because the UI was really bad, but also because you don't need to add another layer and another switch to do. Create strong integration. Everything has an API. We are using Kubernetes that is a framework, and we are using Docker that exposes a really powerful CLI. If we are on a cloud provider, public or private, doesn't matter because OpenShift is it's exposing API. Cloud Foundry is exposing API too. We don't have excuse. Everything is an API. We can collect all our tools and try to join, increase the force of every tools with a well-studied integration. That's the goal of exposing API. The service is exposing API to allow you to fit your use case with that API. If you are just using the basic kind of implementation, you are losing something. Okay, we need a break, and I have something for you. Ah, you are alive. Okay. I was looking at some of you, was like, whoa, I'm sleeping. Okay. The sites is kind of what you get. You have a gift if it's not for you. Okay. Whoa, I can see you better now. Like, we are in the middle of our presentation, and I told you that I have a graph with all the pipeline and that we designed, and that's the idea. We have four environments: pre-staging, staging, pre-production, and production. And our code is moving from GitHub to production. We have a job that runs, is called a peer checker, and it runs for every project every time that we create a new pull request. If you work in the open source environment, you can see like tools like Travis or CircleCI that every time that somebody opens a pull request on GitHub is checking code. We had the same with Jenkins. We have the same with Jenkins, and we run the simple and faster as possible kind of checks that we can. We was working in PHP and Java. We was running JUnit and PHP unit, static analyzation to understand if the cyclomatic complexity was too high or if we was not following standard. Now every language has kind of standard about how to write code. This kind of check is good to have in the pipeline, because if you are not following the right standard, you are not able to merge your code in production. And it took like three minutes to do that. Before we had a periodic job that create our coverage, because we are interested to know the coverage of our project, but we are not interested to wait not 3 minutes, but 6 minutes to have the coverage done. Because I don't know, but like in PHP, it's slow to get the coverage of your test in your application, because it's a calculation that requires some time. We are interested to know that in time we are not like going from 80% to 20%, but we don't need to know that every time that we merge a pull request. And that's why we decided to split this job, because we was happier to have the pipeline fast. Every time that we merge the code in the develop branch, we trigger the artifact creator job that is making, is like the unit test is, we are rerunning the unit test because we don't know how many branch we merge in develop. It means that we need to, like that one is the snapshot of our code that is going to production. We are running unit test, acceptance test, and all the static analysis all the time, and we are making the artifact. This artifact, when it's ready, is triggering the staging build that is taking the artifact and is moving the artifact to our production servers. At that point, we are in pre-staging. For a internal policy, we need to verify that the code is running, and that's why we are not in continuous not in continuous deployment, but we are in continuous delivery, because we are not putting our code in production from 0 to production. We need to have manual checks, but it's something that you can jump if you don't need. Jenkins Pipeline has a feature that is called input. If one of the steps is an input, your pipeline is going to wait for you to say, your code is ready in production, yes or no. It can be a checkbox. If you say no, the pipeline breaks. If you say yes, you can continue. If you don't put any kind of input, the pipeline is moving over and over. At this point, we are in pre-staging. We apply our checks, and we release the code to staging, to the real staging. After that, when we are ready and our staging is working, we make the same kind of things for production, but we don't build a new artifact, because we already have the previous artifact and we know that that code is working in staging. And we trigger a job that put the code in pre-staging. We test code in pre-staging, and when we are sure, we release the code to production, and the release was a symlink change. After that, we merge to, we have a policy to wait for a couple of time, like 1 hour before merge to master. In this way, we can kind of say that our code is working fine, and the merge, for us, the merge branch, the master branch was the stable version. If something wrong was going to happen, we can always roll back to the master branch. That was our rollback policy. And after that, you release your pipeline, and another person is ready to merge and deploy. Like, I'm not saying that this one is this is really complicated. It has some bad point that can be simplified. I was happy to show this one because it was like kind of, the environment was a financial tech company that was like not that flexible, and you can create something complex and achieve any kind of requirements. Like, doesn't matter how your environment seems complicated and less flexible. You can always design a pipeline to make some good challenge. You just need to understand what you are doing. Another example is the pipeline that I'm currently using for my application. And you can see that it's like simpler. And I'm using, like, I designed it. This pipeline is in production from 3 weeks maybe, and my rollback policy is just restart the deploy with a safe version as soon as I can. And the idea is when I merge to develop, I run unit tests and static analyzation. I'm using Docker this time. It means that I'm building my Docker image, my artifact. I'm shipping the artifact to the repository, the registry, and I'm running the deploy to the acceptance environment. I'm using CoreOS and Fleet, and I'm just running fleetctl release or start service. When I merge develop to master, I'm like I don't have like, I'm not running a acceptance test or smoke test yet in the pipeline. I'm running that manually. It means that I cannot go to deployment to production, but I'm going to check. I usually check if the acceptance environment is working. If it's working, I merge develop to master, and the master branch do the same kind of stuff and go release to production. What are the next steps that I'm happy to do in this kind of configuration? The first one that I'm going to do is to use the Docker build. At the moment, I'm running Docker build when I merge to develop and when I merge to master. It means that my image is not the same. My code is not the same between environments. I did that because I was happier to have a delivery cycle more than one ready 100%. And one of the next steps is to build the image in the first step and deploy between environment the same image. It means that I don't need develop and master because I can probably just merge to master and use the same image. Because that's the, like, if you are building artifact more than one time in your pull request and you are not persisting all the tests that you was persisting before, you are lacking in some kind of check because you are not running all the test suite on your code. Your code is compliant only for something and not for everything. Yeah, that's the main one. And close with that, the other one is the kind of snapshot or rollback goal. I'm happy to, I'm pushing the new artifact every time that I have a version in production. It means that I can like switch between images faster without rebuild them. I can just say, okay, pick this image and deploy this image. That's another goal that I'm happy to achieve in order to have a rollback policy really fast because I have my version. I just need to say, put this one. Another stuff that we learn, and it's topic that I already told you before, with the Jenkins server is the entry point, is the unique door for you to release to production. It's the unique one because I hope that you are in a kind of high availability environment and you have more than 2 or 3 servers. It means that you need to deploy really fast to 10 servers, and it's not really the good way to do this kind of stuff. Like what I'm trying to say is that you need to take care about Jenkins as you take care about your production environment. It means that you need to monitor your servers, you need to tail logs and collect them to understand how it behaves and how your continuous integration is growing. You need to have some recovery system because your Jenkins can fail. And what happens when it fails, you cannot go to production. That's it. It's not something good to have. You need to have the edge availability and scaling. Jenkins support like multi-node environment. You can add worker and managers. Managers are replicating configuration. It are the brains of your cluster, and the worker are just taking information from the master, like run these jobs in that node. In this way, you can scale the number of builds. Like you can scale your Jenkins in 2 ways. In a horizontal, in a vertical way, you can just increase your Jenkins, but at some point you reach the limit of your provider. Usually, the smartest solution is add new nodes and scale your build between nodes. And there is a hurdle over there. You need to love your continuous deployment system. That's important, as much as you love your production environment. Yeah, as I said before, Jenkins support master slave. It means that you can add as many as not you can pay for, and you can scale your jobs. Backup and restart policy. There are plugins to do that. I use plugin as the last kind of chance because I'm not really sure about how update them. It's always a pain to understand if they are compatible or not, how they are compatible or not. I try to use as less plugin as I can, and I wrote a bash script that is backupping the Java home and is storing the Java home to S3. And I'm recovering it with another script that is run by the Jenkins, the Chef server, that our infrastructure as code, that when create a new node is just copying the Java home from the backup. That's the idea. I'm not backupping the plugins directory, and I will show you later why not. And this is a snapshot of the Jenkins file that I told you before. Now it supports DSL over, it uses Groovy. If you come from, is a language that runs in Java virtual machine. And you can specify anything you usually specify through the UI in a scripting way. And you have node that it describes where to run that code, because you can have more than one node and you can parallelize nodes. It means that if you have a multi-node environment, you can run your pipeline over nodes. That's a good feature to make your pipeline faster. And yeah, every node has stage, and these stages are block of codes and checks that you can run. In this example, I have a checkout stage that is making the checkout of my Git repository. And I have another one that is the build stage that is running tests, is generating code, and is pushing code. Like it's not like I was just happy to share. It's not really important what there is inside, but it's just the idea that you can specify everything from a file. And as I said before, it's really important, take this file in your version control, close the application, and close the people that are using the continuous integration tool, because they can help you to make it better. Yeah, another idea is that you can, like, I spoke in terms of pull request and code merged from GitHub or Bitbucket or SVN, but there are other, like, thousands of ways that you can use to trigger a build. One of them is the kind of ChatOps environment. If you like write chat ops, GitHub on Google, they are probably the biggest user of chat ops. They use chat to do anything, and they created Hubot. Hubot is, like in this example, you can see that they are asking Hubot deploy Heaven, that is the name of the application, and the robot is taking the message and is deploying the version to production. Hubot is a framework that GitHub created and released open source to create a robot. It's very famous and popular. There are a lot of plugins to integrate with anything else, with anything. And if you are like using Slack or HipChat or ERC intensively in your team, it can be a really good solution to avoid another communication channel, because everything in your company is already happening on Slack, and receive a notification like we have a new version in production, is running great. With Hubot, you can create a graph from your Graphite or monitoring system. It means that you can also ask them how it's loading, and it's going to answer you back with the graph. Like it's powerful. It's in JavaScript and Node.js. You need to know JavaScript, but like the idea is that Slack or ERC has a public protocol that you can use and build your own. I told you that I was happy to leave my colleagues out of Jenkins because the UI was really bad, but I played you. It was a joke because they released Blue Ocean. That is a new UI for Jenkins. It's in version 1, and it's a plugin that you can install, but it's a plugin that they are supporting really well. You can install it, and it's like a new fancy way to start and manage pipeline. Now it is stable. It's version 1. It means that you can install it and try and give it a try. It's really good. I put a screenshot and a URL of the public blog post that they wrote. Like it's good. I told you about that everything needs to be as a code. Pipeline is as a code. You have your infrastructure as a code to create your safe and environment. Plugins are not as code, for what I know. You cannot specify a way from Jenkins to say, okay, just install these kind of plugins, this plugin in this version. It's not something that you can do from a plugin itself, because you don't have the plugin the first time. But it's not easy to do. And in the official Docker image, there is a trick that some guy wrote, and it's really great. You can use the trick with a container or without a container. The idea is that you specify a list, a text file with the list of plugins that you are using, like credentials and the version, Maven plugin and version. You can have a long list of the plugin that you like, and with all the plugins that you are using. And there is another script that is a bash script that I didn't copy paste here because it's too long. But I'm going to share these slides on Twitter as soon as I leave the stage. Yeah, the idea is a bash script. If you know about how Jenkins manage plugin, they are Java artifact jar that you can download, and you need to locate them inside the plugins directory. When you restart Jenkins, Jenkins is reading all the jar and is making available your plugin into the Jenkins system. What this plugin is doing is reading the file that you wrote and is downloading all the plugins. This kind of solution has some problem because if you work with Jenkins before or now it's working the same way, you have a page when you can say, okay, update these plugins, this, and this plugin. And that UI is also updating all the dependency and is managing the kind of combination between version that you have. If you're using this kind of solution, you don't have this facility. It means that you need to know the dependency of your plugins, how they are changing, and how they come together. And it's not really simple, but if you are really looking to have Jenkins set up as a code, you need to have a way to solve the problem of the plugins, and this is one. If you come with something better, just say something to me because I'm interested. Okay, that's the end of my presentation. Thanks a lot to be here. I hope that I answered some of your questions. If you have something to say or some experience that you are happy to share, we have some time, and we have some time. Yeah, you can, as I said before, I use Twitter a lot. You can say hello to me there, and I have a blog and some other projects. I'm running a presentation about Docker security later today. If you have nothing to do, I'm here. Thank you.